In grade 10, we were introduced to the concept of trigonometry on the Cartesian plane, and specifically these things called Pythagoras-type questions. Now, what we need to know in order to do them is that you could draw a triangle in any of these quadrants, and you could end up with an x, a y, and an r coordinate. Okay, and so that's why we have these trig ratios, sine, cos, and tan, in terms of x, y, and r. But also, we need to know that Pythagoras states that x squared plus y squared is equal to r squared. And so we get these specific questions that we like to call Pythagoras-type questions, where we bring a trig ratio like this onto the Cartesian plane, and we solve without using our calculators. So here is a typical grade 10 type question that we would have, and this can still be asked at grade 11 level, and sometimes, although very seldom, at grade 12 level too. Okay, so if 3 sine theta minus 2 is equal to 0 and tan theta is less than 0, without using a calculator, there are all these hints here that tell us that we're dealing with a Pythagoras type question. So without using a calculator, make use of a diagram to determine the value of. Okay, so the fact that they've given us a bit of information here, they've told us something about the quadrant we're working in, they've said don't use a calculator, use a diagram. We've got loads of things that tell us this is a Pythagoras type question. And so what that means for us is that we're going to put this question on pause for now, this actual sine squared plus cos squared. Okay, we know, because we're in grade 11 now, that that's equal to 1, but we are going to prove it. Okay, so let's start by isolating the trig ratio, because that's what we do in these Pythagoras type questions. So the first thing is we'll take that 3 sine theta minus 2 equals 0, and we'll begin to get sine theta on its own. So 3 sine theta equals 2, and sine theta equals 2 over 3. Now, this is not a typical trig equation where I can just pick up the calculator, get a reference angle. No. They've said no calculator, and we need to use a diagram. So what I need then is I need my cast rule, and I need to remember that sine on the Cartesian plane is y over r. Okay, in this case, we're dealing with a positive 2 over 3. So where is sine positive? It's positive in 2 quadrants. Here in quadrant 1, and again in quadrant 2. Okay, the other bit of information they told us was this tan theta business. Okay, they said tan theta is smaller than 0, which means tan theta is negative. Okay, so where is tan negative? It's negative there in quadrant 2 or there in quadrant 4, according to my cast rule. And so now I know I need to be drawing my sketch in quadrant 2. So step 1, we isolate the trig ratio. Step 2, we determine the quadrant that we're going to be drawing in. So in quadrant 2, I now need to pop in a triangle. Okay, and that's going to be 90 degrees there. The coordinates here, so I know that y is 2 and r is 3. So I like to write them in coordinate form. So x, 2, and 3. And then I'm going to use Pythagoras to work out what that x coordinate is, because y is 2, r is 3. So Pythagoras says that x squared plus y squared equals r squared, or in this instance, I'm going to say r squared minus y squared is equal to x squared. Okay, Pythag, so that's just an adaptation there. 9 minus 4, that's going to give me 5. And now I want x. Okay, I've got x squared, so I'm going to square root. Whenever I introduce a root, I do so with a plus or a minus. And so this tells me that x is equal to plus or minus the root of 5. Okay, I'm looking at an x coordinate here in the second quadrant. So that tells me that I want the negative. So that's going to be negative, let's fill that in there, negative root of 5. Minus root of 5. There we go. So now we've got an x, a y, and an r value, and we can then, and only then, solve the question that they asked us. So they said, tell us what sine squared theta plus cos squared theta is, using all of these sketches and no calculators and all that stuff. Okay, so sine, we know, is y over r. Cos is x over r. So let's sub in 2 over 3 squared plus minus the root of 5 over 3 squared, and that gives us 4 over 9 plus 5 over 9, which is 9 over 9, and that does equal 1. Okay, so that's the foundation of a Pythagoras-type question. If they say to you without a calculator and use a diagram or a sketch, and you don't do any of this, and you punch things into your calculator, you get reference angles and stuff, you probably are going to get 0 for that question. So make sure you read the question carefully. If you get information, more information that points to a quadrant, and then some clues about calculators and diagrams, that is a Pythagoras-type question that you are dealing with. If cos 20 equals m, without using a calculator, make use of a diagram to determine the following in terms of m. Okay, so this is a typical grade 11 and 12 Pythagoras-type question. Okay, so we need to just remain calm. I know that often students see things like m and then they think, oh, I don't know anything, I don't have any numbers, what can I do? Okay, but the question has specifically said the answers must be in terms of m. So it's completely fine that we have an m. We need to follow a similar process. So what we always needed to do with the Pythagoras-type question was we needed to isolate the trig ratio. So cos 20, okay, no calculator, so don't work that out, we're leaving it as cos 20, is equal to, now cos is x over r. So I like to then write that like that, m over 1, because that helps me with my sketch. Okay, 20 degrees is in quadrant 1, so I don't need to use the cast rule here. I can straight away draw this in quadrant 1. So I'm going to put my 20-degree triangle in there, 20 degrees. Cos is x, the x value there is m, the r value is 1. And now I can still use Pythagoras to work out the y coordinate. So y squared is equal to r squared minus x squared. Okay, always give Pythagoras credit. So we like to do statement and reason. Okay, and then we can solve this. So y squared is equal to 1 times 1 is 1 minus m squared. And then I'm going to need to square root. And when I square root, I do so with a plus or a minus. So y is equal to, in quadrant 1, x and y are both positive. So I'm going to choose the positive answer there. So positive, don't even need to write that really. 1 minus m squared. 1 minus m squared. Okay, so now I've got an x coordinate, a y coordinate, and an r value. I can solve any of these things that they're asking me to solve. Okay, so the first thing they said was sine of 20 degrees. Okay, here's 20. Sine, I know, is y over r. Okay, so I've just worked out y. It was that whole 1 minus m. Ooh, in the root, I need to write that root down. So the root, let's do that. Sine of 20 is the root of 1 minus m squared over 1, which is just the root of 1 minus m squared. Okay, so that's sine of 20. Cos of 160. Now have a look at this triangle. There's a 20 degree. This would be 90 here, which means this one here is 70. Okay. And so there's no 160 degree angle in this triangle. So I'm going to need my knowledge of cofunctions and reductions to carry on with this question. So 160 degrees is somewhere here in the second quadrant, right? So I can then rewrite this as cos of, and then 160 is now going to be 180 minus 20 degrees. That gives me 160. Okay. And so that in quadrant 2 is cos, positive or negative. Cos is negative here. So that's going to be minus cos of 20 degrees. Okay? Cos is x over r. So I'm then going to say minus m over 1. Or I can go back here and just say minus m is my final answer there for that question. Okay, sine of 250 degrees. Let's just move it to where we've got a bit more space. Sine of 250 degrees. It's such a similar process. Okay, 250 is going to fit somewhere here, because this is 180 and this is 270. So I need to write it as 180 plus something. Okay, so that's going to be sine of 180 degrees plus 70 gives me 250. Now to reduce it, I say, what is sine in that quadrant 180 plus? Is it positive or negative? Sine is negative in that quadrant. So that's equal to minus sine of 70 degrees. Okay, now earlier when I was looking at all the numbers here, I said, oh, well, 20 plus 90 means 70 is left because the interior angles of a triangle add up to 180. But what I could do here is I could say, I'm working with 20, and 20 plus 70 is 90. Okay, and that makes me think of cofunctions, or it should at least. Okay, so I could rewrite this. I'm going to show you both alternatives here, but I could rewrite this then and say, let's say this is minus sine of 90 minus 20, right? Because 90 minus 20 is 70. And then I can say, that's the cofunction, so minus cos 20, and I know what minus cos 20 is. It's equal to minus m. Okay, so that's one option that I had. Another option that I had, and it's so good to have options, that's why I love maths, is to take this minus sine of 70 and then say, well, sine is y over r in a standard Cartesian plane when my angle is at the origin. But I also remember that sine is opposite over hypotenuse. And so I can come into this triangle here using this as my reference angle and say the opposite side, that's the x, over the hypotenuse is 1. So that's going to be m over 1. Okay, and it was a minus, so equals minus m over 1, and that's just equal to minus m. Okay, so two ways of getting the exact same answer here, as long as you remember that sine is opposite over hypotenuse. And then lastly, tan of minus 200. So what does that mean? When I'm dealing with a negative angle, the first thing I do is I add 360. Okay, remember, trig is cyclic. So that's how I deal with negatives, is I say, okay, well, what is minus 200 plus 360? And that gives me tan of 160 degrees. Okay, so now I'm here on my Cartesian plane. I can rewrite that as 180 minus 20. So let's do that. So that's going to be tan of 180 minus 20 degrees. And in that quadrant there, now that I'm ready to reduce, tan is negative because only sine is positive there. So that then becomes minus tan of 20 degrees. Okay, and now I think to myself, right, on the Cartesian plane, tan is what over what? It's y over x. So I head over to my sketch, which I've worked out. Y is the root of 1 minus m squared over x, and the x coordinate there is m. Okay, so that's not a very pretty answer, but it's the answer. So minus, the overall thing is minus because of that. 1 minus m squared over m. Okay, and there we have our final answer for that one. So just a word of warning here, be careful, you can't apply the root. This is where I see a lot of students lose marks in these types of questions, is you're often going to end up with this. So you're going to have 1 times 1, which is 1, and m times m, which is m squared when you work out this Pythagoras. And then when you need to square both sides, you can't split this up and say square root of 1 square root of m squared. Okay, because of this negative here, we need to treat this then as one term, as if there are invisible brackets around this. Okay, and so then for every answer from here on out, we take the whole 1 minus m squared under the roots there, and we use that as our y value. Okay, and even here, when you get to this minus tan of 20 degrees, don't be tempted to try and cancel things. You can't cancel unless you factorize, and we can't factorize this, at least not in a way that would help us. We could get a difference of 2 squares, but it wouldn't be able to cancel with that m at the bottom. And so then our final answer there is just minus the root of 1 minus m squared over m.